Hello and welcome to this mini lecture. It's on the brief history of large-scale sound systems. It provides a nice context for a lot of the other things we'll be exploring in this class, a timeline, if you will, of some of the major evolutions of speaker technology and how they've influenced sound reinforcement. In 1965, the Beatles played Shea Stadium, and they where the PA system was completely inappropriate for the event with 55,000 people screaming, mostly teenage girls. The Beatles, uh, they were reproduced by an array of small column loudspeakers that were designed primarily for voice. And there was no way the audience could hear them. In fact, the Beatles could not hear themselves whatsoever. But this was a kind of a milestone in the rock and roll industry. This was the largest concert of that until that time, and showed everybody that there was a market for this sort of event. And so sound systems needed to evolve rather quickly after that. Just 2 years later, in 1967, at Woodstock, the sound was actually considered a success. Um, a very different sound system approach. At this point, horn loaded, large cabinets, something like 32 drivers per side here, over 10,000 watts of power, large towers, the top 70 feet high and the bottom 20 feet high. The legendary sound engineer of this event was his name was Bill Hanley, and Bill had been handling most of the major events, the major festivals in the preceding years in the whole that style of music. In fact, he actually did the second Beatles tour at Shea Stadium the year earlier and had far more success with his custom-made boxes. And he was using he had designed his boxes based on sort of the horn-loaded theatrical designs, the speakers that were found in movie theaters for many years. And so uh, you could now do large shows. The technology that Bill was using, we call it today discrete systems or stacked or component systems. It's where almost everything is horn loaded. The drivers see a horn in front of them, and horns give you a lot more SPL, and they also directionalize sound. They have a lot of sound quality issues, higher distortion, frequency response issues, but they are quite a bit louder. And in that particular time period, amplifiers were not very powerful and speakers were not that efficient. So this was the best way that it could be done. So stacking speakers on top of each other, obviously there's a lot of issues with that. It's heavy, it's difficult, you can't fly them. They're going to take a lot of space in the truck. It's going to be expensive because of this. And of course, sound quality is going to be, by modern standards, atrocious. Time alignment. And they didn't even know about that, and you couldn't even do it with these speakers. How would you make sure all the drivers are along the same plane? Very difficult. And another interesting thing about this time period was that speakers tend to be manufactured locally or regionally by smaller sound companies. They weren't necessarily built by manufacturers that sold loudspeakers. It was a different paradigm than it is today. Here's a lot of pictures of them out on the web. They're certainly cool by modern standards. You may also want to check out Reggae sound systems. You want to go Wikipedia search on that one. It was cool in Jamaica to compete and who had the bigger sound system. So a lot of really interesting horn technologies, folded horns and phase plugs, and oddly enough, I even got to start on this technology in the 1980s when I started doing sound in the late 1980s in a small town in California. The local sound system still looked like this. Here's Led Zeppelin in the early 70s. You can see what Bob McCarthy calls the flying junkyard. Just stacks of different PA equipment. Here's Iron Maiden in the late 70s. Again, the flying junkyard. Just piles and piles of speakers. Pointed whichever way they thought was appropriate. Just make it loud. Here's a really big show. Piles and piles stacked very, very high of speaker cabinets, and just make it loud. That was a very big festival in the late 70s. So the next big evolution in loudspeakers and sound system design was the one box. I mean, this had started in the 1970s, but by the 1980s it was the norm. The one box is now you have speaker manufacturers designing, a lot more R&D is being done, a lot more knowledge is known about how to make better speakers, and now the amplifiers louder and speakers more efficient. amplifiers more powerful and speakers more efficient, you don't necessarily need horn loading like you had in the 60s and 70s, and you could have direct radiation where the woofers are exposed to the audience, and it sounds better. So now you see boxes that have multiple drivers of different sizes in one box, hence the name one box. Subs are still separate, but at least you might see mids and highs in one box. So there were a lot of advantages to this technology, and we see it still to this day. Consistency in design and manufacture, because brands such as JBL are making consistent boxes that you can use at every show on your tour. Less phasing issues because drivers are closer to each other. Less fidelity issues, distortion issues because of horn loading is not as common. Easier to set up, right? It's lighter, it's smaller in the truck. Less multi-pin connections, less amplifiers. It's just easier. Easier to truck pack and store, and easier to array. And speakers, these one-box speakers were commonly shaped in a trapezoid. They're trapezoidal shaped, so they're easier to put next to each other and form a point source array. Some well-known boxes from this era. There's a variety of them out there, but here's some really, really well-known, famous boxes. The Claire S4 goes back to 1974. Claire still has the S4. It's a four-way, I think. 1, 2, 3, 4 different size drivers. Variety of different technologies, even into the 90s, into the line array era. Meyer MLS4 was quite a box, and that's actually still used by a lot of sound companies. The king daddy of 1980s touring is the EAW KF850. This was the big boy. A long throw box, pretty popular. If you went and saw a big band in the 1980s, chances are it was an 850. Common in this area to array these into large arrays. Point source loudspeakers is a term that's commonly used for these one boxes. Sound emanates from a point. This is in contrast to line arrays, where sound is, when you're arrayed up, the sound is supposed to emanate from a line. So you take a point source loudspeaker and you put it into an array, you get a point source array as opposed to a line array. And so this is a point source array. Sound is emanating from a point above the stage, or to the left of the stage or the right of the stage. So greater SPL, greater coverage when you array them together. Here's a point source array that I mixed on in Bangkok. I think this would have been 2003 possibly. So you can see those. I'm not sure what those are. I really didn't know much about speakers back then. Here's a really big festival in England. I think this is in the early 80s, and you can see here's people stacking speaker on top of speaker on top of speaker, and just a massive, massive, horizontal and vertical line array. Pretty crazy there. The big change happened in the early 1990s. L Acoustics introduces the VDOS, the modern line array. And wow, what a change that was for the industry. A lot of advantages to the line arrays, and we'll explore those in class. The big one, I think, is just the simplicity in rigging, of being able to rig off of one point, or maybe just two chain motors. It's just a lot easier. Line arrays had been around earlier. It was in the late 40s when Harry Olson wrote a book where he kind of proposed the idea of how drivers would interact with each other when arrayed vertically. The earlier implementation of this technology was the column loudspeaker, and this was popular in bar bands, that sort of, schools and that sort of thing in the 1960s and 70s, the column speaker, but never was loud, never was full PA. Oddly enough, if not ironically, it was the Beatles were playing through little column speakers. The Beatles in 1965 at Shea Stadium, when nobody could hear them, they were actually playing through line arrays. Kind of ironic, I suppose. But key to the success of the line array, the modern line array, was we were in the computer age at this point, and manufacturers made loudspeaker prediction software. And you guys in this class are learning MAP, but there's other ones: D&B Array Calc, and JBL Line Array Calc, and L Acoustics Sound Vision. And these all have their strengths and weaknesses, and they're all pretty cool. The main idea is to kind of predict how speakers are going to interact with each other and how they're going to throw and different frequencies, and it's pretty cool. And part of this, introduction of the line array and the introduction of loudspeaker prediction software was the need of manufacturers to educate their clients. It was such a big a paradigm shift to the line array from point source arrays that loudspeaker manufacturers really needed to teach their clients how to array them and how to angle them and how to use the software. So education became part of it. Now, the next big change, and we're really on the cusp of this now, we are in the moment of sea change. Uh, the technology has a variety of different names. Multicellular, adaptive, numerical. Essentially, these newer speakers, these newer arrays, instead of articulating the array, that is, angling the array to point these different boxes at different rows in a line array, you actually achieve the angling via DSP. These boxes, and this is the AW Anya, has 24 drivers per box. That's hundreds of drivers in this whole array. The array does not angle at all, it just hangs vertically. Yet by using phase interaction between all these little tweeters and the mid-range drivers and the woofers, you can actually steer the sound in various directions and avoid balconies or avoid certain areas of the theater that aren't sold, or change the coverage after you hang the array, and all sorts of stuff. This is called beam steering. That's one term they use for it. And typically the actual DSP involved is all pass filters or FIR filters, maybe a little delay and EQ, but it's pretty complicated. It's very computer driven, and this is the future. It's very exciting. Here's a nice little comparison. This is from Martin MLA product material. The traditional line array, where every speaker in the array is basically being driven by the same signal. A more advanced version of a line array, and we'll do this in class, where you shade it. Maybe you turn the treble down on the bottom of the array so it's, the close people don't get blown away. Or maybe you turn the treble up at the top of the array so you can throw it farther to farther people. The multi-cell array, like the Anya and the MLA. In this case, almost every speaker has its own amplifier, has its own DSP, and a variety of processing is done at the per speaker level. And it's pretty cool. It's the future. It's very complicated. It's gonna, you guys are gonna see it happen. So pretty exciting. Anyway, this is a nice overview of the technology, from the 60s onward in large-scale speaker systems. Have a great day.